Hello, I'm Don Ward, Chief Executive of CIB, and welcome back to CIB in Conversation. Today, we're pleased to welcome Michael Lacasse. He's a leading board member of CIB, a coordinator of one of our working commissions, and he has a day job at the National Research Council, Canada. But just before I introduce you, a reminder that CIB is the global network for collaboration in research and innovation in the built environment. And a warm welcome to everyone who's joining us today, and I hope you'll enjoy this conversation. I have a feeling you will. For more information about what we do, how we add value for the global network, please see the website that you can see on the screen behind me. So our conversations are all about meeting the personalities behind leaders in the world of built environment research. And as I say, today we're joined by Michael Lacasse. Michael, hello.
Yeah, good day, Don. It's good to see you.
It's good to see you too, and thank you again for making time today. So let's kick off by giving you an opportunity to introduce yourself, Mike. What's your current role in and involvement in the world of research and innovation?
Yeah, I'm a senior research officer at the National Research Council Canada. I oversee the Facade Systems and Products Group. It's a group focused on research related to, as one can tell, facades, but it's walls and window products. And I oversee the research work of a staff of about 8 researchers and an equal number of students and 5 or 6 technical officers. So that's a very challenging opportunity. Apart from that, I also participate, as you mentioned, in CIB activities. I've been involved with CIB since 1994, since my first trip to Lillehammer in Norway, with the CIB W80, which is the Working Commission on Prediction of Service Life of Building Materials and Components. And I'm still associated with that group. I help coordinate that effort together with Dr. George De Brito out of the University of Lisbon and Bruno Daniotti out of the Politecnico di Milano. And yes, as you mentioned, I'm a recent addition to the board of CIB.
You are, and thank you very much for your contribution to CIB. Mike, we'll talk more about that later, and indeed we'll come on to talk perhaps in a little bit more detail about the world of facades. But you know, a lot of our people who watch these videos are interested in your background. You know, how do people get into these positions? So what brought you first? What got you started? What brought you into the world of construction in the first place?
Well, I'm a graduate civil engineer.
Yeah.
And I graduated in '77 from Queen's University, and I went to work for the James Bay Energy Corporation in geotechnical investigations as I started out first 3 years of my career in engineering, and that was in northern Quebec to help develop the hydroelectric projects that were being built at the time. Following which, how shall I say, the isolation of the far north didn't appeal to me so much, and so I went back to university and took up a master's degree at Concordia University at the Center for Building Studies, and my supervisor, how shall I say, he said, you know, you could get your PhD. And my wife at the time was wondering whether I was ever going to finish my studies, but I somehow I managed to convince her that it wasn't such a bad idea, and I completed a PhD at Concordia University with the late Dr. Dorel Feldman in 1991. The very same year I took up a position as a research associate at the National Research Council.
Oh, and what was the PhD in, Mike?
Well, the PhD related to the use of a byproduct of pulp and paper industry, lignin, and combining that with different types of polymers to make sealant products. So sealants and caulking compounds are used to seal joints in buildings, and although they're a rather uh, innocuous component to the building, no one really thinks a lot about them. But as it turns out, they're rather important because otherwise, the system, the entire system, is not so waterproof, nor does it offer a barrier to air leakage of the assembly. So sealants are, as I found out, a rather important component to all of
Okay.
that. And
Yeah. And,
so I
and
did my PhD in that, and I was lucky enough to get a position at the NRC exactly to do exactly that, following up on the work of Clara Carpati, who was the then guru of sealants at the National Research Council.
was that because the university and Concordia and the NRC, you know, worked closely together? They knew of each other's work and were involved. Is that how they come to get to know you?
Well, as it turned out, there was as it typically is in government. There's always changes in cadre every so often. Government has different initiatives, and it was recruiting new members, and I was people from the who were already working at the NRC came to recruit me at the university, and uh, evidently they thought that I might fit in, and after a few interviews with this person and that person, I got a 2-year term position as a research associate, and my career thereafter started in earnest.
So if I understand correctly, you spend your first 3 years after your first degree, you spent 3 years in the industry as a graduate engineer. Then you spent some time doing a master's and PhD, and then into the world of government research. So as we often find with these conversations, how many people have worked in industry and then gone back into academia, as it were.
I could say that
Uh,
the industry experience was quite something, and
yeah.
it certainly puts you into the world of achieving really practical things. And that certainly was the case, if one can imagine working in an isolated camp in northern Quebec with not much else, but well, with what much else but a handful of other colleagues, and a few wood buildings in which very flimsy wood buildings in which to live, and basically it's you and the black flies.
So I guess you'd be an advocate then, would you, of a period of industry expertise, even if one envisages the rest of your career to be in academia or in research?
I would. Thanks very much for that question, Don. Yes, of
Yeah.
course I would. Yeah, I think it's very valuable. Um, Mind you, I also tell people, like, get as much education as you can as quickly as you can, and that sort of precludes being able to go to industry. But I think the working with industry, getting a sense of how things are actually done is good. Mind you, these days, as unlike when I went to university as an undergraduate, uh, uh, younger people in undergraduate degree have the opportunity to go through co-op programs. So the cooperative programs permit them to work in industry whilst they're doing their degree, whilst they're earning their degree. So this is a huge plus when they graduate with their first degree, as they've already gained useful industry experience. And so
What's the practicalities of that, Mike? As cooperative may not be a term that's used everywhere around the
yeah,
world.
no, basically one is so I should say scholastic terms, if I can put it that way.
Yeah, yeah, okay.
There's a 4-month term where uh, the the student would work at an industry of his choice, um, in an area that would be somewhat aligned with what he's doing. Of course, you don't always have the opportunity to pick exactly what you want, but
Yeah.
in many instances, industry or companies are in need of such type of support from students for a 4-month period. And it's of course the students are very hardworking and earnest, and they earn every dollar they make. So it works both ways, both for industry and for young people to gain the experience in the field. That's so very important for them to get a better understanding of when they're actually designing things or
Yes.
thinking how to innovate. What are the practical issues behind implementing all of those innovations? A rather important thing to ensure that whatever you're putting together is actually going to function.
And so, how would you sell the benefits of that model of sort of that thin sandwich model to industry firms who maybe haven't engaged with universities on such programs?
Well, presumably this is an approach that many different countries are already implementing, and it's I assume, and I would encourage industry, those in the construction industry that can take advantage of students in the summer work term or whichever work term that they might be available, to contact the local university and ask them what are the possibilities of being able to engage their students over a 4-month or more. I mean, sometimes they can have 2 back-to-back 4-month periods,
Right.
which they can work. So that's also very interesting.
Okay, so Mike, we've got you as far as joining NRC after your PhD. When you first joined, did you think you'd be there for the rest of your career, or the rest of your career to date, anyway?
Well, I still recall the conversations I had with my wife at the time, and they were, well, she said that she wasn't all that keen on moving to Ottawa because we had been living in Montreal, which she very much liked. And she says, well, it's good for a couple of years. We'll see after that. I didn't say anything to that. I was very happy. I was very excited to be able to work at the National Research Council. I still am.
Yeah.
In fact, I've never been. It's very strange how things have. Well, strange. There's never a dull moment. That's for sure. And so I've enjoyed my career up to now, and I continue to enjoy it. And it was a very good situation that I took up. So yeah, I had hoped I didn't make any. I had hoped to stay for a long period. Yeah.
Oh, great. Well, I mean, one of the very noticeable characteristics of all our conversations with industry leaders is how much people enjoy working in this sector, whether it's on the industry side or policy side or research side. So you're another in that category, if I might say so. Can you give us an early highlight from your time there? What was sort of something that stands out as a particular landmark that you achieved?
Well, what I achieved, I'm not the particular landmarks were being able to, I should say, the experiences that I had traveling abroad were quite remarkable. And I started out, as I told you, in the area of looking at research related to assessing the performance of sealant products. And I soon found out that the industry how should I say, has always got a new sealant product that they've already formulated several years in advance of the current products they're selling out there. And so the type of research that they might have access to, that we might be able to provide them with, it didn't offer many opportunities for industrial collaboration. And because at the time when I started off at the National Research Council, there was a great interest in linking much more closely to industry, and engaging industry and supporting the research that we did. I wasn't getting a lot of traction there, and it was decided that perhaps I might make a greater contribution if I broaden my my horizon beyond sealants, and started looking at how water gets into wall assemblies, and what was it, and basically what are the physics? What's the physics? What are the elements that come into play when one's looking at the penetration of water, or rainwater, I should say, through wall assemblies and window and wall assemblies. And so, in that sense, I did make a few advances regarding assessing the water tightness of different types of wall assemblies. And early on in my career, I guess we undertook a very elaborate consortium project with several different industry partners, looking at aspects related to how walls perform when they're subjected to different climate loads, and the extent to which they can the extent to which they can maintain their performance over time to those loads, depending on the location of the wall assemblies and so on. So I had an opportunity to really get to move my career from just simply looking at joints to looking at the entire wall assembly, and looking at issues related to moisture performance, long-term moisture performance, and durability of those assemblies. So that sort of started things off in the next phase of my career, which was more along the lines of moisture performance of wall assemblies and wall components.
And just before we sort of go into that, perhaps in a little bit more detail, Mike, before we leave the world of early career researchers, have you any tips or advice that you would pass on to current students? As you know, we've a very active student chapter network, and we've an early career researchers network. What would be your advice to those communities?
Indeed, and so you said network. CIB has a network, and the fact that they've joined those networks is exactly what I would recommend. One of the very positive things that I found was being able to participate in international networks of researchers, to get a much broader perspective than one would otherwise get. For example, if one was working in academia, and I'm not saying that there's not academia, a good number of academia that participate in CIB activities. There are indeed, but not everyone is attuned to it. And these are very positive things that researchers can take up early on in their career, where you're able to work together on common themes, and get to know the measure of more senior researchers, and how they see the research horizon. That's very useful, a very useful a very useful piece of information to be able to acquire early on in one's career.
So how did you come to be involved in the CIB, following that train of thought?
Yeah, and so there was a great interest in bringing durability to the building code in Canada in the early '90s, because there had been issues related to durability of wall assemblies in the Vancouver area in around that time frame, mid '80s to early '90s, and there was a complete breakdown of a lot of the wall assemblies, because basically the people that were putting up the assemblies weren't well trained enough to understand the basic information that well, they weren't building to the building code. Is
Right.
basically
Yeah.
the cusp of it, and there were a lot of premature failures. And so there was a great push to have issues related to durability explicitly written to the building code. And so there was this more senior cadre had interest in some of us reaching out and finding out what others were doing across the globe.
Right.
And so I was asked to participate in the W80 working commission, and so there was interest in. So the International Research, the Institute for Research and Construction, now the Canadian, the Construction Research Center, had interest in some of us reaching out and finding out what else was going on around the globe in regards to durability, as it were, durability of components and whatnot.
Right. Yes.
We were also in the process of putting together our own standard on design for durability of buildings. And so I was asked to attend this meeting in Lillehammer in 1994, and met for the first time the leaders of the W80 Commission on Prediction of Service Life. And how shall I say, I've made career-long friends since that time. People that I started out with still have contact with.
Yes.
The leader at the time was the coordinator at the time was Christer Sostrom. I still in communication with Christer, although as he said today to me, well, I'm getting old. I said, no, you're not old. In my mind, of course, he's never old.
Yes.
But he's nearing 80. So he was a great mentor for me, really excellent person to work with. And he got me involved in many of the, not only did he get me involved in W80, but he got me involved in the activities of putting together a World Congress in 1998 in Gävle, Sweden. That was a unique experience because it was he had asked me to put together a symposium. I've never done that before. 150 participants. So there was a question of having to arrange for all the different things that one would need to arrange for in such a symposium. There were 4 parallel symposia ongoing at the World Congress. That's how he had organized it. So he got me involved in that. And then the year after, he got me to say yes to putting on a conference on durability of building materials and components, the triennial conference of that particular working commission.
Right. Yeah.
That he had hosted in 1996, I guess it was. And that I attended, and so I didn't quite know what I was getting into, because that particular conference, the eighth DBMC in the series, was held in Vancouver, which is not Ottawa, and which made it all very interesting. But we had a great participation, and the people that I met there, and the contacts that I made, I made career-long contacts at that conference. It was wonderful to meet other people and network with them, and a very positive thing indeed. Now, it's not an easy thing putting on a conference, but certainly has its benefits.
And were you able to get the input that you needed to solve the challenge of what needed to go into the building codes on durability? Did they work with the CIB Commission directly contribute then to some of the answers?
I would have liked to have said yes, but the building code is overseen by a committee of volunteers. The National Research is simply the custodian and helps maintain that and provides technical support. So the decisions with regards to whether or not durability, it is in the building code. It's not explicitly in the building code. However, having said that, the standard that was published in 1990, I can't remember now, 94, I guess it was, on the design for durability, the design for durability of buildings. I just finished revising that from a guide. It was a guideline, not a standard. It is now a standard, a Canadian Standards Association standard, and it will be referenced in the building code. And that happened this past year. So it's taken a few years.
It's taken a
So
few years, hasn't it? But then building codes
it's taken a
can move
career.
slowly. Yeah.
That's right, Don. It's taken basically a career to get these things into the hands of practitioners, and we're still working towards helping practitioners get the issue of durability straight. So we have several other documents that we feel will be able to help them, in particular when it comes to climate change. That's our next big challenge.
So let's talk about that next big challenge then. In your own capacity, how what dimension of climate change are you particularly looking at?
Right. So it's all about the loads to which the wall needs to respond to, or does respond to.
And are those becoming more extreme?
So we're looking at, that's right. We're looking at extreme climate events, and well, there are two issues really, and it's a bit of a challenge. One of them relates to overheating in homes. If we wish to keep the elderly, those people who are vulnerable to extreme heat events and potential overheating in their homes, such as the elderly, the sick, and the very young. And so the issue there, of course, is how does one maintain proper comfort so that no one gets ill and they remain safe in their homes. That's one issue, overheating. Of course, juxtaposed to that is the issue of energy usage and saving on energy, uh, be that cooling or heating and so on. So one needs to have the proper types of approaches to be able to achieve the outcomes that we wish. In other words, safe indoors, but also um, uh, taking energy usage into consideration. The other aspect is the long-term performance of wall and window assemblies going forward. This is all about maintaining the worth of one's assets. Uh, if should those assets be subjected to more extreme climate events going forward. And what are we talking about in terms of extreme climate events? We're talking about extreme events of wind-driven rain that may bring about premature deterioration of the components in a assembly over time. And we've been looking at um, how different types of walls we've been looking at how different types of walls respond to climate loads. The climate loads we're talking about are wind-driven rain, pressure difference, wind speed, wind-driven rain, pressure differences, temperatures, relative humidities, and so on. We know it's going to be a warming climate, which means that for many of our structures in Canada, many of the residential buildings and the homes and small buildings, many of these are constructed out of timber, and one needs to be very careful about how the assembly is put together to ensure that moisture doesn't penetrate the barriers and otherwise affect the wood-based components, so that they deteriorate and decay prematurely. And so this whole issue is about maintaining the value of our assets going forward. It's not a unimportant thing at all. A person will their most important an individual's family's most important purchase is their home, and if they lose the value of that home over time because of weather effects, that's a problem. If insurance rates go up because insurers don't know what risks there might be, that's an issue for homeowners. So all of these aspects together, uh, of course, more information on how existing and new building assemblies will respond to extreme climate events in Canada is all important to be able to maintain the value of the assets and ensure that insurance doesn't get out of hand.
So how fundamental do you think the changes or the improvements might need to be, Mike? I mean, are we talking a 10 to 20% improvement, or are we talking about something radical? And if I could put that another way, are the biggest challenges around the materials and components themselves, or the systems, you know, the integration of the products and materials into systems, or is it around the workmanship aspects where the biggest challenge will lie?
The workmanship aspects have always been there. They always will be there in a sense. If we continue building as we do, which is basically stick building, which means everything is done on site from individual wood elements. I'm talking about homes now, not commercial buildings. So that's an issue that needs. I mean, that one can get around that by adopting factory built homes and so on. And but there hasn't been a huge push towards that in recent years, although things are slowly developing in that.
Do you think that will become a bigger trend in Canada?
It's an excellent question. I don't. My crystal ball is foggy on that, I must say.
Yeah, fair enough.
So I'm not able to pronounce on that one way or the other. There seems to be an increasing trend, but you know, how else is, you know, to what extent that's going to change in the next few years is difficult to say. It may very well accelerate if the number of trades, the availability of tradespeople is reduced, and so because basically you need quite a cadre of tradespeople to be able to erect buildings on site and so on.
And apologize if I missed it, but is the performance gap sort of 10-20% issue, or is it a fundamental improvement in the standard and the quality of buildings?
Yeah, no, well, okay. So coming back to your question before, I mean, you know, how to what extent does one foresee climate change is going to affect buildings going forward? So we talked about with regards to productivity and so on. I don't expect that in the near future. So I'm talking about the next 30 years. There are going to be a huge need for significant changes to the way in which the building code addresses climate change. I think we're going to be able to manage reasonably well with what's already in the building code. However, beyond that, if one's thinking about making a structure that is required, and I'm talking about homes, because by and large, homes can have a life well beyond a generation. In other words, 20 to 30 years. Well, and there's, you know, there's a whole group of homes in Canada that are several generations old. But typically the home is paid for in a few generations, so that's not an issue. What is at issue is those buildings, those more important buildings, if I can put it that way, those more expensive buildings, the larger buildings, for which the service life is 75 years and beyond. In that instance, one really needs to be able to take climate change into consideration, because the climate will significantly change in that period. There's no doubt about that. And then the question is, how important might the changes be, and what added expense may there be? And you know, is it out of the realm of possibility that it might be 10% or 15%? Certainly not. That doesn't seem to be unrealistic, in my opinion.
Have you any thoughts on what part digital will play, or smart buildings and smart controls and so on and so forth, and the interaction of digital into the mix alongside workmanship and products and systems?
Yeah, so there's digital on two sides of things: digital in the design, which is building information models, BIM.
Yeah.
And that's an up and coming trend, and they're increasingly getting sophisticated. and they will be increasingly useful to help make decisions um, uh, that basically decisions related to the service life of the built component itself, of the built assembly of the building. And these are hugely important elements, because that means that we'll be able to integrate the life cycle assessment through the proper choice of elements, to which BIM offers an opportunity to be able to do that. And as well, we'll be able to incorporate issues related to climate change in those models as well going forward. So these are hugely important elements from the design side of things. From the operational side of things, of course, um, this is all about reducing waste in waste of operations in buildings. When we're talking about operating a building, we're talking about operating it from the point of view of heating, cooling, lighting, and other services. So pumping water up to the 40th floor or whatever. And so with regards to be able to manage all of that, clearly there'll be advances in that area. Already we're seeing, for example, elements related to occupancy in different spaces of the building, where heating and cooling is reduced if no one's there, lighting is not on. And when people populate a space, well, then the services operate. So these are the types of things that presumably are going to be more commonplace going forward.
And just a thought as well, you mentioned homeowners and how they should be concerned, bearing in mind it's what a significant investment it is for them over their lifetime. But extending that just a little bit, how concerned do you think banks should be, and insurance companies, you know, given their exposure to the asset? And you know, should they be taking more interest in this area of research and innovation?
They absolutely should. They want to ensure that someone is going to continue paying their mortgage, or they're going to continue to see value in paying their mortgage going forward. They don't want to see loss in value of their assets either. And so there's every reason for them to understand what risks they're running going forward, be they reinsurers or be they the banks that offer homeowners mortgages and so on. So yes, thank you very much for that question.
Well, we'll have to see if we can get that message across, Michael, to that sort of that community, won't we? Which does allow me to say that you know, what is it now? Under 2 years since CIB relocated our headquarters to Ottawa, and whilst as we record this, it's 15 months since COVID, you know, enforced a lockdown on us. So certainly I'm not in Ottawa at the current time. But what sort of benefits can you see from CIB being headquartered in Ottawa in the future?
Well, one of the benefits is once you relocate to Canada, I'll be able to talk to you face to face, in person. I think that's a huge benefit. I'm very much looking forward to being with you and working directly with you. But certainly, one of the benefits is with regards to being able to expand the services that CIB offers to members, by virtue of the fact that there are savings to be had from having relocated in Canada.
Yes.
Savings in regards to the operation of CIB. So this is, in my mind, hugely positive. And we hope to be able to capitalize on all of that in the months ahead.
Yes, and you're absolutely right to draw attention to that, Mike. I also feel like we're a bit underrepresented in terms of the research community in Canada. Some of the top universities there, you know, NRC are closely involved with us, clearly, but there are other important actors, I think, who I hope we'll be able to engage better once we're on the ground, as it were. And kind of before we come to a close, Mike, a couple of questions. One is, I've already mentioned we're recording this and we're still feeling the effects of COVID pandemic. Are there any, what effects do you think that pandemic may have, or you know, the lessons learned of the last 15 months in thinking about your area of expertise, facades and buildings generally. Do you know, is there any area where you can think, well, actually, you know, life will never be the same again, and this is a new area that's opened up that we'll be looking at now for the foreseeable future?
Well, okay, so I've been involved in an initiative, as it turns out, relating to reducing the contagion of potential contagion of individuals in working spaces. I developed a Eureka project on this with two European participants, one in Germany, one in Sweden, and several small and medium-sized enterprises in those countries and in Canada. The focus of that work relates to ventilation and devices that cleanse the air. And I can see that going forward, not simply from the basis of this particular virus, but all future viruses. Certainly, there are certain organizations that are going to be looking into installing devices that allow the ventilation systems to provide clean air. This is a very important element, clearly, that we hadn't earlier considered, but now understanding how important all of those aspects are. This has been the focus of work here, and so we're at the National Research Council. We have several test facilities that we're going to be using to give some idea of how the aerosols transfer themselves in these spaces, and what can be done about that from the use of different types of devices and so on. Using, of course, a basic a tool of simulation to be able to infer from those results what occurs in different types of spaces going forward. The information is focused on looking how, for example, one might differently manage long-term care facilities, health facilities, and so on. So this is one aspect. The other aspect is the fact that people have stayed at home and worked from home. There may be a great interest in having that trend continue, and we may very well find that there's a smaller requirement for office space going forward and fewer buildings down the road. So exactly how that's going to play out, I'm not sure.
Well, ladies and gentlemen, unfortunately, our recording cut Michael off at that point, but I hope you agree that he gave us two great examples there of the impact of the global pandemic in his area of work. And it's very striking that we have over 40 working commissions, and every single one of them identifies an aspect of their particular expertise, which is going to be forever impacted and will change the way that business is done, the construction and built environment process is done in their field. So it's really an exciting area of development for CIB to capture all the different ways in which our industry is going to change as a result of what we've learned or experienced during the pandemic. So unfortunately, we weren't able to reconnect with Mike. So I apologize for the rather abrupt end to the chat, but I hope you enjoyed it. He's a great guy, Michael. You know, we love having him in the CIB. He brings so much energy to the discussions. He's really committed. He's particularly keen to see CIB grow and make an impact in Canada. And as you heard there, we look forward to working with each other really to make that happen in the future. So if you want more information on Mike and his work, I think you could see it on the screen behind him. It had his own website there. Otherwise, you can easily Google the NRC in Canada. Other search engines are available. So I'll sign off. We always welcome feedback and any suggestions for future interviewees, or any changes to the format you'd like to see, or any interesting people, as I said, that you'd like us to chat to. So please contact myself or my colleague Debbie Gray at any time, and we'd love to hear from you. Meanwhile, that's it for today. I'm Don Ward. I'm the Chief Executive of CIB, and I hope you've enjoyed our latest edition of CIB in Conversation, with many thanks to Michael Lacasse. Thank you.